Hello friends, this is Rupesh and I'm watching CPP Minutes video series on data structure, and this video should have been the first video, and I'm going to put this video as a first video in this series, or the second one, because I'm going to explain what data structure I'll be using in order to store tree, graph, these stuff like directed graph with weight, and undirected graph with weight and tree and all that, okay? Because it is very important to actually understand that how you are going to store it and how you will iterate so that you can get maximum benefit. So as the topic says, store graph and tree in vector of vectors. It is good for programming competitions. So before actually starting a data structure or algorithm series, you have to know that, okay, how you are going to store them. If you have any knowledge on programming competition, you would have seen your inputs like this, where they will tell you that how many number of nodes are there, how many number of edges are there, and if there are weights from one node to another node, then they will provide that also. So how to store all those things? Let's see. So the note says there are different ways to store tree and graph, but I prefer vector of vectors. It is also called adjacency list. Yes, you might have seen adjacency list, how it works. If you don't know, don't worry, I'll explain all these things to you. So as I said, this is the input. So let's create this graph. So this 5 and 6 are nothing but number of nodes and then number of edges. So this 5 denotes number of nodes in tree or graph or whatever, and this 6 denotes number of edges. So after that, this is just the information that from one node to another node, this is the edge. So 1 2 3 4 5 6, total 6 edges. So let's draw these edges. It is saying 1 to 2, so 1 2 2, and it is not directed graph, so you can go from 1 to 2 and 2 to 1, no problem. So 1 to 3 here, and then 2 to 3. Now the question comes how you are going to store them. So this is the answer. See, first they will tell you how many number of nodes are there. So you take it, then they will tell you how many number of edges are there. You take it. Now you create vector of vectors. Why this? I'll tell you later. First, let's suppose you have created vector of vector, and you do the resize of n plus 1, because n they have given, in our case it is 5. So you have to create one extra, because indexing work from 0. So if you'll say 5 here, then it will create from 0 to 4, but we actually want till 5, so we have to give one extra here. So if you will do this, how it is going to look like? Let me move this. So this is our graph, and if you did this line, what it means? It means if you're asking for 6, it will create a vector of 6 size. Okay, so from 0 to 5, and in these vectors we have another vector which will actually store these integers. So notice this, the syntax is vector of vector, meaning this outer vector will store inner vectors. So actually this is pointing to another vector, and similarly this is pointing to another vector. So that's why I told you it is like an adjacency list. Now if I want to tell you that node number 1 is connected with node number 2, something like this, this is connected with this one, so how you will store this inside this one? You just have to tell that vector of 1 push back vector of 2. I'll write it, vector of 1 dot pb vector of 2. And as it is not directional, it is not like you can only go from 1 to 2. No, you can go to 2 to 1 also, right? So you have to do another way also, like you have to say vector of 2 push back vector of 1. Sorry, this is round bracket. So this first reference is to refer this array, and then this number is added to the array contained inside these boxes. So if you are saying vector of 1 push back 2, meaning this is 0, this is 1, so you are saying that I am pushing this 2 inside this, so it will look something like this. You have 2 here and this is 1, okay? And if you're saying vector of 2 push back 1, so this is your second, because this is responsible for pointing the outer vector, and then you're pushing 1, so you will have 1. It's that simple. So this is how you store this whole data using while loop. I'm saying that how many number of edges are there, keep on giving the edges to me like u and v, and I'll do u push back v and then v push back u, because I'm going to talk about undirected graph. Okay, so I think we are clear now how to store undirected graph. And then let's look at this undirected weighted graph, and then we'll see directed graph, because directed graph is very easy. If you are just saying that from u to v only, meaning you will just do this only from u to v, you will not write this line, and then that directed graph is done. And problem starts, not problem, it is little tricky when it comes to weighted graph. So let me tell you how we will solve that issue. So I'll undo now. So as you need a weighted graph, so now there are not 2 values, there will be 3 values, meaning one will tell, okay, from 1 to 2, and the weight is, let's suppose, 5. So now your input would look something like this: 1 to 2, 5, then 1 to 3, maybe 2. Then we have to have this weight variable also, so that you can have it. So after this C in UV, you will have weight also. Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now. And now there is a trick here. You will not have vector of vectors which will store integer. No, we will have pair. So std pair of integer comma integer, just like that. And we need to follow one convention, that first guy is a node and second guy is a weight. And now here what you will do, you will use make pair, and then you will say v comma w, and if it is undirectional, then you will come here and you will say make pair of, wait a minute, u comma weight, just this much. Now what we are doing is, see, before we were storing numbers in these vectors. Now we are not going to store numbers in these vectors. We are going to store, because their type is now pairs. So this particular vector, this one, not this one. So this is the outer vector which will always be dereferenced with the number 0, 1, 2, 3, 4, 5, 6. Inner vectors are of type pair. So one element of this one will now contain a pair. So for this input, let's say 1 to 2, weight is 5. So this is your 1 here, 1 to 2. So you would say that now it will be storing something like 2 comma 5, because now we are storing pair. And why you have to do this second line? Because I told you, you will always do this second line when there is undirected graph. If there is a direction saying that, you will always go from u to v, meaning you will have only first line, you will not have second line. But now as we are discussing about the undirected graph, we have to do these 2 lines. Okay, so I think this is clear, this is clear, this is clear, this is clear. And let's talk about tree. But I don't think we have some special case with the tree. You will always store data like this only for the tree also. And yeah, wait a minute, if you do not like this pair thing here, let me change it. You can use some node or some data type, I mean plain old data kind of thing, which will be giving maybe more insight. But let's call it a node. Okay, and wait, so integer I will be small here, so don't worry about that. Now you can use this node type here instead of this pair thing, and if you don't like all these things, you can simply use this. Let me create it. node tmp, or just call it small node, and v, and similarly I'll just copy paste here, and this is going to be weight, and this is, and you have to say that this is going to be the vector of node now. Sorry, so it's up to you what you prefer. I have used this also, and I have used pair also. It doesn't make big difference. And yeah, then you have to change this part before initializing into this one. So you have to make it u, and then you will say node here. Then also you are doing the same thing without using pair and all, if you don't like that idea of mine. Okay, so I hope you understood the point here. And if you're looking for how to iterate over this vector and get all these values, so if you don't know, then just go ahead and watch my DFS video, or you can go for BFS video. You will get how to iterate over it. I do not want to waste the time here. You can go ahead and check that. So thank you guys, and I posted this video after so long time because I was not keeping well, so I could not create videos. So I'll see you in the next videos, guys. Bye bye.